Discovery of neutron. Here we are discussing how discovered the neutron. We know that deuterium and tritium nuclei, that means isotope of hydrogen, contains only one proton each, but the masses of nuclei of hydrogen, deuterium and tritium are in the ratio 1:2:3. Therefore, the nuclei of deuterium and tritium must contain, in addition to a proton, some neutral matter. The amount of neutral matter present in the nuclei of these isotopes, expressed in units of mass of a proton, is approximately equal to 1 and 2 respectively. This fact indicates that the nuclei of atoms contain, in addition to proton, neutral matter in multiples of a base unit. The hypothesis was verified by James Chadwick, who observed emission of neutral radiation when beryllium nuclei were bombarded with alpha particles. It was found that this neutral radiation could knock out protons from light nuclei such as those of helium, carbon and nitrogen. The only neutral radiation known at that time was photons. Application of the principle of conservation of momentum and energy showed that if the neutral radiation consisted of photons, the energy of photon would have to be much higher than is available from the bombardment of beryllium nuclei with alpha particles. The clue to this puzzle, which Chadwick satisfactorily solved, was to assume that neutral radiation consists of a new type of neutral particles called neutrons. From conservation of energy and momentum, he was able to determine the mass of new particle as very nearly the same as mass of proton. The mass of neutron is now known to a high degree of accuracy. It is Mn is equal to 1.00866 U is equal to 1.6749 into 10 raised to minus 27 kilogram. Chadwick was awarded in 1935 Nobel Prize in Physics for his discovery of neutron. A free neutron, unlike a free proton, is unstable. It decays into a proton, an electron and an antineutrino, and it has a mean life of about 1000 seconds. It is stable inside the nucleus. The composition of nucleus can now be described using the following terms and symbols. Z atomic number means number of protons, and neutron number means number of neutrons. A mass number means total number of protons and neutrons, which is equal to Z plus N. One also uses the term nucleon for a proton or a neutron. Thus, the number of nucleons in an atom is its mass number A. Nuclear species or nuclides are shown by the notation AXAZ, where X is chemical symbol of the species. For example, the nucleus of gold is denoted by AU 79197. It contains 197 nucleons, of which 79 are protons and the rest 118 are neutrons. The composition of isotopes of an element can now be readily explained The nuclei of isotopes of a given element contain the same number of protons but differ from each other in their neutron number. Deuterium H12, which is an isotope of hydrogen, contains one proton and one neutron. Its other isotope tritium 1H13 contains one proton and two neutrons. The element gold has 32 isotopes ranging from A is equal to 173 and A is equal to 204. We have already mentioned that chemical properties of elements depend on their electronic structure, as the atoms of isotopes have identical electronic structure. They have identical chemical behavior and are placed in the same location in the periodic table. All nuclei with same mass number A are called isobars. For example, the nuclides H13 and He23 are isobars. Nuclides with the same neutron number N but different atomic number Z. For example, Hg8198 and Au79197 Au are called isotones.